My name is Nikhil Pote, and I'm the lead gameplay software engineer at Dream Game Studios. To give a brief about myself, I've worked as a key gameplay programmer for many gameplay titles that have been downloaded by millions of users across the world. I've also worked with multiple sports franchises to get gameplay experience in sports. Some of the major franchises include Australian Open, French Open, and ATP. And now, we are into cricket. So today, me and my colleague, Ruturaj Patkar, is going to give a talk on optimization flows to build a AAA mobile game using Unreal Engine. How many cricket fans over here? Awesome. So our next 30 minutes are going to look like this. We are going to talk about our upcoming AAA mobile game, Dream Cricket 2024. Then how did we all begin to use Unreal Engine, our journey with Unreal Engine? I hope it is audible, right, everyone? Clear? Awesome. Then we'll share some insight of our gameplay development team with respect to the optimizations that we have been doing over the past decade. Then we'll cover optimizations right from art to the gameplay. And at the end, I'll introduce you to our game architecture that we have come up with inside our cricket game, which allows us to scale and grow our game. And lastly, I'll scribble out some tips that are required to do inside an Unreal Engine editor so that it is very easy to build games for Android. All right, Dream Cricket 2024. Jatin, आज कौन सा मैच चालू है? Yeah, it's India versus Sri Lanka today. The game that is happening right now in a cricketing world is the same game you can play inside this game. India versus Sri Lanka. The game is available in early access on Play Store. It's a AAA mobile cricket game from India where user can enjoy player versus player multiplayer and challenge their friends to see who has the best dream team. It's a game developed by Dream Game Studios. Have you heard Dream Game Studios, guys? Awesome. It's one of the exciting gaming studios currently in India, right? It's a gaming studio of Dream Sports. Dream Sports is one of the top profitable unicorn with popular brands like Dream11, Fancode, Dream Set Go, and Dream Sports Foundation. Let's take a sneak peek at our trailer. Well, that's the answer. How did you find it, guys? The quality that you see right now over here, it is same that is there inside the game right now on Android. All right. 1.5 years back, we decided to switch to Unreal Engine. Last year when I came to IGDC 2022, I gave a talk regarding how did we switch from other game engines to Unreal Engine? And it was a journey in itself. So we had a vision for this game. It was to create an immersive and authentic cricket gaming experience that captures all the excitement, the strategies, and the real life emotions of a cricket match right at your fingertips. Our game should take the user to the heart of the stadium where he can choose the player that he likes, right from past to present, and participate in a thrilling, realistic cricketing action. So our vision elements included creating high quality 3D graphics. We chose Unreal Engine for the same. We wanted cricket realism with respect to the batting, the bowling, the fielding, the stadium atmosphere, and the crowd cheering. We wanted to include licensed teams and players to maintain the authenticity. We wanted to cater both the hardcore cricket fans and the newcomers by providing different game difficulty and different game modes. We wanted to create an engaging gameplay which allows the user to strategize around the batting, around the bowling, and you can play around the realistic physics and fiddle around the control systems. We wanted to add a social aspect around the game where user can connect to anyone around the world and have a cricket match, challenge a cricket match. We wanted to keep scalability right from start. We wanted to churn in user feedback that we are currently getting in the early access and give the community back by immediately rolling out the updates. We wanted to capture, as I mentioned, the real life tournaments that are happening inside the game, the real life events that are happening inside the game, right inside our cricket game. So that was the vision statement that was set. So our journey using Unreal Engine. Let's have some nerd talks now. So 1.5 years back, we started to train our entire team to Unreal Engine editor. We got a huge support from the Unreal Epics instructors, the developer community, and the forums around the world. We started to do some prototypes. We came up with character pipelines that we must use inside Unreal, the art pipeline we must use inside the Unreal with respect to the vision that we have, the gameplay pipeline that we must use. And after a lot of prototypings in the pre-production stage, there were a lot of chaos. We went through those chaos, and the results were surpassing our expectation benchmarks. How many Unreal Engine developers over here? Awesome. So you guys know gameplay framework, right? It's one of the most robust framework which has all the content that a programmer needs to spawn anything in the world. We stuck with it. Let me give you a development insight that were happening inside our team in the last decade. Let me share a history about ourselves. We were Rollicle Games at start. Anyone who knows Rollicle Games? Right. We were Rollicle Games at start, got acquired by Dream Sports, and got rebranded to Dream Game Studios. We were the pioneers of mid-core and VR games in India. We were the creator of multiple international award-winning games. We won the NASSCOM GDC award in 2015 for our game Dead Among Us. All these games are mobile games. We won the People's Choice Award for our sports game Flick Tennis. We won the Silver Edition Award for our tech Rollo Motion. We were the finalist at South by Southwest in 2019 for Interactive Innovation Awards. If you'll see all this game, right from sports to adventure to action, we came through a changing horizon of high-end device and low-end smartphone devices. What low-end smartphone devices is right now was a high-end smartphone device 3 to 4 years back. Optimization was always a challenge for us. I'll give you a brief about Rollicle. Back then in Rollicle, we used to develop games with our own proprietary engine called Rollo Engine. It was based on OpenGL. We had our own texture formats. We had our own mesh formats, and etc. So we were already imbibed into all of these things. Let's get to optimizations now. What is optimization? Optimization is like filling a big slice of bread inside a small lunch box. right? If you struggle to mix those bread inside the lunchbox, you're going to end up in a mess. But if you plan it to cut in pieces and then perfectly fit into the box, it's going to work. So optimization is for seamless gaming and uninterrupted realism. I'll give you another analogy. Let's say that there's a dance performance I want to do. I'm going to wear a tuxedo and look glam, right? And I need to dance for 2 to 3 hours. That's not possible, right? Looking glam and at the same time wearing that tuxedo and dancing for 2 to 3 hours is difficult. So I need to find a balance between looking glam. I need to have an outfit wherein I can look glam plus I can dance for 2 to 3 hours. It's same for optimization and for creating games on smartphones. It's about achieving a balance between performance and the visual quality. And lastly, we have profiling tools that are available. But when we went into production stage, we choose what is our target market? What is our target group? Whom do we want to target? What kind of smartphones do we want to target? What kind of graphic processor we want to target? What kind of graphics API we want to target? What is the RAM usage that we want to target? What kind of display quality is what we want to target? So we divided our project into phases. Like phase 1, let's target these kind of settings. Phase 2, let's target mid-level devices, and then low-end devices. So that's how our optimization journey began. I'll share some key optimization jargons right now that became a talking language between our team, the tech art team, the gameplay team, and the art team. So these jargons are used for budgeting, right? Firstly, what kind of game are we building? It's a game of cricket. What are the importance? The characters are important, right? Then you have the stadium. What is the budget for polygon, the vertex, and the faces? What are the faces that are visible? What kind of texture resolution that we are going to go with? There's a good concept of mesh morphing that is available. Are we going with that? Then what kind of atlasing are we considering? We need to have a planning for that, right? Atlasing is something not just a world. We need a proper planning. Okay, what are the kind of players that are going? What are the props that are going inside the stadium and all? When it comes to smartphones, 2 types of compression. You guys have seen these compression types? Right? ATC to ASTC, PVRTC, right? Right? So we artists follow this PNG, JPEG and all, right? But graphics processor knows this. ETC to what is ASTC, right? These are the compression standards. They demand us to create your texture in a power of 2 for Android. But for iOS, it demands us to create a texture in power of 2 but squared, right? These are the learnings that we had over the past decade amongst our team. Then occlusion culling. Occlusion culling is something which allows you to take the camera somewhere and see, okay, whether there is a CPU hog, whether there is a GPU hog at this viewport of the camera. Then we have draw calls. Draw calls is something that I'll cover later while I explain optimization characters in detail. Then we have batching, LODs, and how is the VRAM usage inside the GPU. Everything comes with its own advantages and drawbacks. Use more LODs, you are going to spend more RAM usage. So you need to have the balance between everything. So this is how the optimization process looks like in our team. We take the measurements with respect to the budgetings that we saw in those jargons. We look at the bottlenecks, determine what is the better optimization. Like for example, if 1024 texture is not working out, I just scale it down. But it is going to hamper my quality, right? Are there anything like, then there are techniques like MIP mapping that I can use with respect to the device resolution. Determine the optimization, apply those optimization, and this cycle continues. My view with respect to the metrics, that the 2 metrics that allow you to tell whether your game is running smooth or not is one is your own eye. Your eye is able to see that jitter. Don't even go for profiling at the start. Look at the budgeting that you are using. Try some other budgeting variables. And the second is not FPS, but the frame time. Whenever you are asking your friend to wait, right? So you ask the friend, okay, I'm coming in 5 minutes, I'm coming in 10 minutes. But it's similar for a GPU, right? For GPU, it's like, okay, I'm going to render in 8 milliseconds, 120 FPS. 16 millisecond, 60 FPS, right? So this one metric will allow you to know, okay, there's something wrong that is happening when the camera is moving around this certain session and all. So this is the optimization process that we keep on following. We set the computation budget, play around with options like VSync. During the optimization process, one of the tips is that we switch off the VSync and see if there are any tearing and all. And why is there a tearing? When it comes to optimization, optimization is everywhere, right? From your art, characters, animations, environment, to your gameplay, your mechanics, your input, your networking, the multiplayer game, your design, your audio. It's everywhere. But the one team that creates those miracles is your tech art team. Let's start with art and optimization in characters and animations. The game demanded us to create multiple characters, the players, right, of the teams. How can we scale this? We determined that, okay, we need to create body parts, body types with respect to the players. Then how do we assemble it? It's a common technique that we use nowadays, that we create a same rig for the different body parts. But since there are different body parts who are running inside the game, they are going to cost you draw calls. How do I merge them at runtime? Unreal Engine already had a solution with respect to Unreal Engine's modular character system. Give different body parts. At runtime, it will construct and just have the character assembled, just reducing your draw calls. We did level of detailings at the mesh level, but we didn't stop there. We went for the bones also. The characters that are near to the camera, we need to capture their expression, their celebration. But the characters who are far from the camera, we don't need those expressions. So we included LODs at the bones level also. So characters were actually the backbone of our entire gameplay, with their props on, the pads, the helmet, the gloves, and then the faces. This is Will Young, a guy who played yesterday's match between New Zealand and South Africa, got out for 33 runs. This is the reference that we had, and this is the sculpt that we have inside the game. So we wanted to maintain the authenticity. My lead character artist, Sudesh Patil, is over here. I just want to ask a question to him. How did you scale 300 plus characters inside the game?
Yeah, so we started with the 300 characters in 6 months. We have achieved that. You can see this character we have created in 1 day. So this is a part of our pipeline, character creation pipeline. So to achieve this, we have spent 1 month to get this output. And also, when we started this, we gave the full freedom to create 300 characters in 6 months. So our team was really working hard on this. So, and then after, when they were working on this, so we didn't give them any pushes like to create the. We are creating this to get integrated in mobile games. So they were working we were creating this for AAA, right? So. And yeah, then the tech team was integrating this inside the game engine. Yeah, cool.
All right, thank you, Sudesh. So as Sudesh mentioned, We gave freedom for the artist, not think about mobile devices. Just create, just create. The tech art team, in tandem with the art character team, sat down and converted those however texts using normal maps and right inside the game. Some of the tips when it comes to optimization with respect to characters and animations. One is use map maps, but again, it comes with its own drawback of memory. I would suggest no transparency at all. You're going to cost the Z buffer. Use modulated shadows, which is one of the good feature of Unreal Engines for mobile devices. All right, I'll switch over to Rituraj, who will be describing the optimizations for environment. Thank you.
So yeah, my name is Ruturaj. I'm lead game environment artist at Dream Game Studios. So yeah, when we started planning for the environments inside Dream Cricket 24, the first thing came in our mind was, the maximum screen size will be covered with environments when user will play the game. So environment has to be equally good looking, but with characters, I mean. But at the same time, environments has many things like skies, vegetations, in our case, stadiums, crowd. So it has to be optimized as well. So we decided let's divide environment in two parts, like common assets and uncommon assets. So under common assets, as I mentioned, those will be like skies, vegetation, or say crowd, which will be constant in every stadium. And then in uncommon assets, there will be a stadium structures, which will get changed according to stadiums. But as we progressed, we found that we need those variations in the common assets as well. But while doing those variations, we did not want to add those multiple meshes, textures, or say materials inside the game. So we came up with the solution that we can do that with mesh instancing or say material instancing, so that we'll get those variations without adding those extra meshes or say materials. So here you will see, this is our ground mesh, where I'll get an options to change the color of grass, color of the pitch. I can change number of pitches or say pattern of the grass without changing the mesh or the uh, parent material. We are using single mesh, a single set of PBR textures, and one parent material for the ground. So we followed the same method for rest of the common assets. Then coming to the uncommon assets or say stadium structures, there we followed the standard pipeline for the optimization that was, mesh modulation and texture atlasing. But while doing texture atlasing also, we kept to only one texture for the whole stadium. And while planning the mesh modulation, we plan the modulation in such a way that, we can use tileable texture inside that atlas also. Then as Nikhil mentioned, we avoided alpha textures inside game as much as we could, because at the time of stress testing, we found that, alpha textures are way heavier for processing than static meshes. Then there is feature in Unreal Engine which helped us a lot. That is, they gave us multiple viewports where you can check the compatibility or say complexity of your scene inside engine itself. Like if you can see here at the bottom right, the greener part is lighter for processing and the red part is quite heavier for processing. So we tried keeping things in the green as much as we could. We avoided red parts, or say we rework on the red part to convert it into the greens. Then coming to the lighting, so in our environments, you can say almost 99.9% things are pre-baked light data or say baked lighting, because we wanted to give that margin to the characters for the real-time lighting and real-time shadows. Even you're seeing some things like flags or say trees which are moving or animated, those are also static meshes, and we are animating it through material calculations. Then last but not the least, our take art team, which was really helped us while doing this, like camera occlusion culling, or say texture atlasing, or say texture map mapping, which allowed us to use good quality textures and meshes inside the game. So yeah, that was the brief journey of our environment art in Dream Cricket 24. Thank you very much.
The game is currently live on Play Store through early access. There is a QR scan over here, QR code over here. You can scan that code and download it on your Android phones. But user feedback. We want to churn the user feedback every time. We want to give the community what they want with respect to game. But can we do it immediately? We want the updates to roll out quickly. That is why we built an architecture on top of Unreal. There's something that we are exposing for the first time over here. Complex. Isn't it? How many programmers over here? Awesome. Cool. I'll make it simple for you guys. So we divided our game into two containers. One is a gameplay, and second is a meta game. Can anyone tell me what a meta game is? A meta game is nothing but, anyone? Meta game? Yeah? Right. Meta game is nothing but a game that is built on top of a game, where user is going to interact, select the different modes, select the different difficulties, select his controls, select his settings, and get inside the game. It gets more complex when you have different kind of modes, right? Tournaments, you have match of the day, you have multiplayer game, you have a private match that you can host with your friends. Then you are covering all the major leagues, right from Super Smash to Legends League inside the game. How can we scale it? So what we did is we maintained a container which is core to the game, that is a game of cricket. We kept Unreal Engine's gameplay framework right over here. We decided to go with state machines for the game flow that is happening. But state machine example could be, when I'm transitioning from one inning to another inning, it is driven by a rule. And that rule says that the number of balls for a 20-over match is met, or the number of wickets have fallen. The state gets transitioning, right? So we achieve modularity for our programmers where you just concentrate on the functionality, right? What you have to write in that state. One of the key things that we achieved is, from a single code base, we drive our multiplayer and standalone mode. We achieved it by having adapters at gameplay input side. What is a multiplayer thing? It's nothing but an online input with respect to AI, right? AI versus an online input versus a touch and HUD. Simple concepts that are packaged inside the core gameplay has nothing to do with the meta game at all. Let's come back to the meta game. There are different game modes. User is going to select, do some settings around it. At the end, it is going to construct a meta game, which the game mode at Unreal Engine side is going to understand and is passed through to the gameplay container via loader. Our user widgets, if you'll see, are completely reactive to the data changes that are happening through our live ops. What are the advantages of this architecture? At the right bottom, if you'll see, right from the moment I tapped on the game icon to the game, it took me less than 10 seconds to get inside the game. the stumps that are there inside the game, it was easier for us to create variation of animations for the stumps. Create different animations with respect to the different ball speed, the angle of incidence on the stump. But we didn't do that. We went with Unreal Engine physics, wrote our physics on top of it, resolve those collision and have the variation of stump. When Breathley balls a ball at 160 kilometer per hour, the stump just rolls and goes back. That's the reality that we achieved. So the advantages are that we could load the game faster, the feature testing became easier for us. Due to the containerized nature, the game became crash tolerant. It is programming friendly, we achieve scalability, and single code based drives are multiplayer plus standalone. We're going to scribble some tips so that you can test it out on Unreal Engine Editor. Most of you guys might be knowing these tips, but it might be helpful for you guys. There are certain settings that we can test Android development right inside the Unreal Editor. You can have a preview rendering level to Unreal ES 3.1. Convert, as Ruturaj mentioned, convert all those material complexity which are showing red into green. Use alpha, you will see that it's getting red. At the UI level, it's straightforward. Try usage of invalidation box as much as possible and retainer box. Lastly, with respect to the different profiles and devices that we have, right from low end, mid end, high end, ultra high end, you can have a base device profile setting inherited inside your project by mentioning, okay, what is the scale resolution that I'll go with for this kind of devices, for this kind of GPUs, right? And you can create your own profiles also, whether you want to enable these settings of post-processing for low-end device or high-end device. We're still into the early access. There are a lot of optimization that are still remaining to do. We are in an optimization journey ourselves. We want to target almost 99% of the Android devices and the iOS devices that are there. We see a great potential as we build our own AAA mobile game, one of the most ambitious and biggest game out of India, Dream Cricket 2024. The beta access is available at dreamcricket.app. Please follow us on Instagram as Dream Cricket app. Join our Discord channel. Then please subscribe us on YouTube. Thank you. We are open for question, guys. I'll also like to get my team over here. Ruturaj, Sandeep. Yeah.
Can I ask? So, is your game multiplayer game server authoritative? Is the multiplayer game server authoritative?
Yeah.
So, the major challenge for any multiplayer game is the network latency. So, how did you manage that?
Yeah. So when it comes to game of cricket, right? It's all about planning. Okay, what are the packet size that I need to send? And one of the major thing is, can I just replicate things inside my game itself, right? So what we did is we started with, okay, let's spawn everything at the server. Okay, we started with that. Major challenge when it comes to game of cricket is a bad ball connect. How are we going to achieve that? Turns out that we went on solving a lot of networking problems, reduced the packet size, reduced a lot of things, but it didn't work. But our physics was so deterministic with the architectures and underlying mobile architecture. We segregated in such a way that, okay, let's do most of the things at the mobile side, reduce as much network packet as possible. Awesome. Yes.
Yeah, what's the full form of these terms like AAA games, 4A plus games? primarily, and when you had chosen cricket as your game to just create to use the real players, didn't you have licensing issues because you cannot use if you need to use Sachin Tendulkar's name, you need to just take permissions from him and perhaps copyrights from BCCI or something like that?
Yeah. So first of all, let me give you what AAA thing is, right? Let me explain what a AAA thing is. This is my perspective, right? So right from Rollicle, right? So we were a team that was small sized, right? We used to create mid-core games for tennis and action games, adventure games. What the only hurdle that used to happen is, oh, we want to achieve a high quality that is there, that is benchmarked on PC and console, right? How do I do that? I need to increase my budget. I need to increase my budget, right? So AAA quality is having a 3D, high quality 3D graphics with a high budget. And when it comes to licensing, yes, there are the players that we showed, we already have license with Dream Sports. We've been a part of Dream Sports, and we do face, we have a legal team that is on board. We are constantly in touch with them. What are the contents that goes inside? But what can be done? Can we create any characters that is little alike, 50% alike, and all? That is what the mesh morphing thing was when it comes to optimization and all. Cool? Awesome. Yes.
From the screenshots, it looked like you're using Unreal Engine 4.
Yes. We're not into Unreal Engine 5 yet, because when we started, Unreal Engine 5 was still experimental. We had done a lot of researching and prototyping, though Unreal Engine 5 looks very promising with the features that we have. But in future, we are going to go to Unreal Engine 5, but currently we are on Unreal Engine 4.27.2 plus.
Thanks.
Awesome.
Hi, amazing talk by the way. Had a
Thank
lot
you.
of fun. I have two questions. So the first one is, did you guys dig into the source code to do any kind of optimizations?
From the programming perspective, I'll share you something. You guys use fixed update inside Unity? Right? So Unreal Engine, we wanted something like fixed update, right? It's all about accumulators that we want. So we had to dig a lot into source code. We had to make changes inside source code, wherein we can have the sub-stepping thing, which is still experimental inside 4.27, and have a deterministic physics.
My other question is, were there any tools built during the development phase for the art team or the dev team?
Yeah, so when it comes to optimization, right, so the tools that I would like to mention is, from the editor perspective, you have session frontend that is there for Unreal Engine. Plug into your Android device, you'll get all the graphs that are happening, what are the bottlenecks. As I mentioned, one metric, frame time. Look at the frame time, right, for the GPU, for what the CPU and all. Session frontend, then we have Unreal Insights. We're not able to find the memory usage, right? So Unreal Insights allowed us to have those memory usage, we could quantify the memory usage also. Okay, how much are the assets taking up inside the meta game, and how much are the assets taking up inside the game. And along with that, there are like multiple tools like Game Bench, and your Android Studio is one of great, has one of the great profiling tool, is one of the great profiling tool. Cool?
Yeah, thank you.
Awesome, man.
Hi, here. So about the characters, lead character artist Sudesh. You said like you made 300 characters in around 6 months, right?
Yeah.
That's like a very large volume.
Yeah.
So how big is your team? I was just wondering.
Sorry?
How big is your team to achieve like?
Right now we have 10 artists.
Okay.
And you can see these characters that we have created. It's a one-day output from starting with the likeness and till the render screenshot. And also integration part was handling our tech team. Yeah,
Okay, still a great feat.
yeah. Thank you.
Sorry, you mentioned you're not doing a determinism from the server side, right?
Yeah.
So doesn't that make it like, how do I say this? If the determinism is happening on the client side, uh, doesn't that make the packet data to not be like have to be dynamic sized because everything, every entity has to be updated on the server?
Not necessary. The reason being our physics was deterministic, realistic and deterministic, right? So when I say deterministic, right? So every mobile game has a different architecture, right? When it comes to iPhone and Android, the floating roundoffs that are there on iOS versus the floating roundoffs that are there on Android, they're different, right? But what we did is we managed around having a deterministic physics via which if certain character is running in this time at this position, the same character runs at that time at the same position at the device level itself. So there are very less packet transfers that are actually happening inside the game.
So does that mean like the packet layout for the memory will always be the same whenever you're sending it, or will it change based on whatever is
It
happening?
will change based on what user input is with respect to, okay, I'm going to take one run. Okay, it's just a boolean that we are setting, right? It keeps on changing. I think time's up over here. But any questions? All right, one more thing. Please download our game, give your feedback, and we'll give you what you want inside the game. Thank you so much, guys.